Okay, folks, we're moving on to Objective 3. Now, on Objective 3, we're adding and subtracting rational expressions, which means there's a new thing involved, and that is the common denominator. That's the biggest difference between multiplying and dividing. When you multiply and divide, you don't need a common denominator. When you add and subtract, you do. Now, Worksheet 3 has quite a few concepts in it, so I'm breaking the problems down. The first set of notes that I'm going to do will cover problems 1 through 9. Now, just like anything else, we're going to start off with the easiest. I'm going to add two rational expressions, ugly fractions, but luckily they already have the same denominator. So at least I'm starting off with a common denominator, which means I know what my denominator is going to be. It's going to be 2x squared minus 11x minus 21. So what do I have to do to the numerator? I just have to add them, combine like terms. There is no other x squared, so I know x squared. I'm going to take this minus 15x and add it to 3x, and that's going to make minus 12x. And I'm going to take this 20, and I'm going to add the 15, and that's going to give me plus 35. Now, that's my answer, but now I need to simplify it by factoring and reducing what I can. So here's where the factoring skills come into play again. The numerator is just a regular trinomial factor. Factors of 35 that have a sum of negative 12 would be x minus 7 and x minus 5. Now, this is factorable, and if it's a guess and check, if you do it as a guess and check, you might have to play around with a couple of different combinations, but what you're going to end up with is 2x plus 3 as one of the factors, and x minus 7 as the other factor. So now that we've got it to this point, my x minus 7s can reduce each other, and I'm simply left with x minus 5 on the numerator over 2x plus 3 on the denominator. And there's my answer to that problem. Example number 2. The good thing about example number 2 is, yes, they still have common denominators. It is a subtraction problem, which does add one wrinkle to what we're doing. Let's take care of the denominator first. I know my answer is going to have a denominator of x plus 5, because that's the common denominator. Now, this minus sign, the 4x minus 3 up here is a binomial. Now, it isn't presented with parentheses around it, but I'm going to put parentheses around it, and that's just going to remind me that this subtraction sign needs to get distributed to the 4x, and it gets distributed to the minus 3. So my numerator is the 3x squared plus the 20x plus the 2, and then minus the 4x, and then when that subtraction sign hits the minus 3, it makes plus 12. Now I need to simplify that numerator. I know my denominator is still x plus 5, so I've got 3x squared. A 20x minus a 4x is plus 16x. That 2 added to that 12 makes 14. And this would be a guess and check factor also, except it doesn't work. So you'd be here all day guessing and checking because there isn't a pair of factors that make this work. So there's your answer. All right, moving on to example number 3. It's an addition problem, as you can see. Our denominators are not common denominators. In fact, they're exact opposites. So I'm going to rewrite this first fraction. I'm not going to do anything to it. X squared plus 13x minus 5 over x squared minus 4. Now, I'm going to turn 4 minus x squared into x squared minus 4. I'm going to turn it around. And the way we do that is multiplying by -1, which all that -1 is going to do is going to turn that plus, it's going to turn this addition problem into a subtraction problem. And now we're where we were on the previous problem. Don't forget that 4x plus 17 should be considered in parentheses because that subtraction sign needs to get distributed to both. Now, let's see where we are at this point. I'm ready to subtract these two fractions that have the common denominator of x squared minus 4. The numerator, there is no other x squared in the problem, so x squared. This positive 13x subtracted by that 4x is 9x. This negative 5, and then when this subtraction sign hits plus 17, it makes minus 17. So negative 5 minus 17 is minus 22. And now it's time to start cleaning this problem up. The denominator is a difference of perfect squares, so I can factor it as x plus 2, x minus 2. The numerator is a trinomial that does factor. The factors of negative 22 that add up to positive 9 are x plus 11 and x minus 2. And as you can see, the x minus 2's reduce each other, and you're left with simply x plus 11 over x plus 2. Now, example number 4 is a little bit different. I have monomial terms down here. So I've got to figure out what's going to be the least common multiple of this problem, otherwise known as the lowest common denominator. Now, since these are monomial terms, they're not common right now. Let's take the coefficients first, 8 and 12. What would be the lowest common denominator using 8 and 12? And the answer is 24. Now, x and x squared, what would be the lowest common denominator? It would be x squared. Now, this fraction has a y and this one doesn't, so the common denominator would have to include the y. So what we've found, by finding our least common multiple, we've actually found our lowest common denominator. It's 24x squared y. Now we have to figure out, what do you have to do to each of these fractions to increase the denominator to be 24x squared y? Well, we're going to take this 3 right there, and what does it take to turn 8 into 24? Well, it takes multiplying by 3. So that 3 would be needed to multiply by 3. This denominator has x, but the common denominator has x squared. so I also need another x. Now, this denominator has a y, and the common denominator has a y, so I don't need to do anything with the y's. Moving on to the second fraction that begins with a 7. This one already has x squared in its denominator. Well, the common denominator has x squared, so I don't have to do anything as far as x is concerned. But this denominator does not have a y in it, and the common denominator does have a y in it. So this one needs to be multiplied by y. Now let's see where that takes us. We've got 9x over 24x squared y plus 7y over 24x squared y, which means my final answer is simply going to be, I can't really add these because they're not like terms, so the best I can say is it's 9x plus 7y over 24x squared y. Hopefully those 4 examples will get you through problems 1 through 9 on worksheet 3. The next 3 examples are intended to help you get through problems 10 through 15 on worksheet 3. On example 5, notice, we're still adding. That's what worksheet 3 is pretty much all about, adding and subtracting, which means you need common denominators. Well, this denominator is a binomial x minus 2. This one is a totally different binomial x plus 5. So what that means is my common denominator is simply going to be made up of x minus 2 times x plus 5. Now, for each one of the numerators, we're going to start off with what the numerator already is, 4, and then we're going to look and see, well, this denominator already had the x minus 2, but what it needs is the x plus 5, and this fraction's numerator was 1, and this fraction had as its denominator the x plus 5, so what it needs to pick up is the other denominator of x minus 2. So, everybody now has everything they needed. The 4 needed to get the x plus 5, the 1 needed to get the x minus 2, and now we're ready to bring these two together through addition. We know the common denominator is x minus 2, x plus 5. The numerator is 4x plus 20 plus 1x minus 2. I'm just distributing that 1 plus 1x minus 2. Now, when you simplify this, you get 5x, 4x plus 1x is 5x, and then 20 minus 2 is 18, so 5x minus 18 over x minus 2 and x plus 5. Now, if this numerator were factorable, I'd go ahead and factor it and see if anything cancels or reduces, but it isn't even factorable, so that numerator is as good as it gets right now. In example 6, in order for us to know what we're working with right here, I need to factor this denominator. Now the factors of negative 24 that add up to negative 6 are x minus 6 and x plus 4. So I really don't need to think of that denominator in its unfactored form anymore. So I'm just going to cross it out so nothing gets confused. So this denominator has x minus 6x plus 4. This one only has x plus 4. So they both have the x plus 4 in common, but this one needs the x minus 6. So my first fraction really doesn't need anything. It's 7x plus 3 over x minus 6 x plus 4. Now notice we are subtracting. That may or may not play a little bit of a crucial role, but we're not there yet. This second fraction needs as its common denominator x minus 6 x plus 4. It already has the x plus 4. So the only thing it needs to pick up is the x minus 6, which was in the other fraction. Now, here's where you don't want to cancel or reduce. You can't yet. We need to bring these two together as one through the subtraction process. So I know the common denominator is going to be x minus 6 times x plus 4. The big question is, what's the numerator? It's 7x plus 3. Now here's where that subtraction sign needs to be distributed. Think of this as a negative 2 being multiplied by this. So negative 2x, but then when negative 2 is distributed to minus 6, it makes plus 12. So keep cleaning up the numerator. The denominator really isn't going to do anything for a couple of steps. So 7x minus 2x is 5x. This 3, which is positive, plus that 12, which is positive, makes plus 15. Now notice the top is factorable. So I'm going to go ahead and factor it, whether or not it helps us or not. I'm going to factor out a 5, and you're left with x plus 3 over x minus 6 x plus 4. Now, it really didn't help us because there isn't a factor down here of x plus 3. But if there was a factor of x plus 3 down here, we'd have been able to cancel the two x plus 3's. And there's your answer. Okay, the last problem for the section that would be for problems 10 through 15. Example number 7. This one's going to take quite a lot. In order for us to figure out what the common denominator is going to be, we need to factor these denominators to see what they're made up of. So x squared minus 25 is a difference of perfect squares of x plus 5, x minus 5. That takes care of that. The second fraction, I can factor this, factors of positive 10 that add up to negative 7 is x minus 5 and x plus, no, it's minus, x minus 2. So now I've taken care of that. So now I've got to figure out what in the world is going to be my lowest common denominator with these two terms. Well, they both have x minus 5 in them, so that's good. That's already common. But this one has x plus 5 that this one doesn't. So they both need the x plus 5. And this one has the x minus 2 that this one doesn't. So they both need the x minus 2. So there's the common denominator in its factored form. Everybody has to contribute something to the common denominator. Now, this numerator was 10. And if you look at what this denominator already had, the only thing that the first fraction needed was to pick up the x minus 2. So the 10 gets multiplied by the x minus 2. Now on the second fraction, if you look at what the denominator was already made up of, it was the x minus 5 and the x minus 2. So the only thing that the second fraction needs to pick up is the x plus 5. Now it's time to bring everything together. We know the common denominator is x minus 5 times x plus 5 times x minus 2. This numerator makes 10x minus 20. Now remember, this is distributing a negative 3, so this numerator is minus 3x minus 15. Remember, you're distributing that subtraction sign as if this was a negative 3. Now the next step would be the cleanup step. Again, we don't do anything with the denominator. Just leave it in factored form. The last thing you want to do is make that a big old mess by trying to multiply it. Now, 10x minus 3x is 7x. And then this negative 20 minus 15 makes minus 35. Now, the final step would be the denominator is already in factored form, x minus 5, x plus 5, x minus 2. The numerator can be factored, so let's go ahead and factor it. Factor out a GCF of 7, and we're left with x minus 5. And notice we've got some x minus 5 that can cancel. And that's your final answer. After those x minus 5s reduce each other to 1, there's your final answer. 7 over x plus 5, x minus 2. My last 3 examples are intended to help you get through problems 16 through 23. Example number 8. Now we venture into the world of what they call complex fractions, fractions within fractions, and you want to notice where the main fraction bar is. It's right there. So we've got, everything above it, which is fractions, everything below it, which is fractions. Now, the key to cleaning this ugly mess up is multiply all terms by the least common multiple. So, look at all the denominators. I've got a y and an x, and I've got another y and another x. What would be the lowest common multiple or the lowest common denominator if 2 of the denominators were y and 2 of them were x? Well, the least common multiple would be the product of x, y. So that's the key to this entire problem. Everything gets multiplied by x, y. So I would have, this is the way I show my classes to do it. It's like just a really large distribution problem. XY is going to go to every single part of this problem. I'm distributing XY. And remember, distribution means multiplication. So I'm multiplying every single numerator in this problem by XY. So look what happens when I do this. It would be 4XY over Y plus 2XY over X. And that would be all over 9XY over Y minus 5XY over X. Now I'm taking the really long way around on this problem, but just to show you how it all works. So every single numerator in this problem got multiplied by XY, and this is what I have now. Now let's go through one by one and cancel and reduce what we can. On this first one, the Y's would go away. On this one, the X's would go away. Down here, the Y's would go away. On this one, the X's would go away. And what you're going to end up with is a much cleaner version of the problem, because here's the main fraction bar. The top is simply 4x plus 2y. The bottom is 9x minus 5y. Now you may have noticed that the numerator can be factored by a greatest common factor, so I'll do it. I'll pull out a 2, and I'll be left with 2x plus y over 9x minus 5y. Now it really didn't do anything because there isn't anything that can reduce with 2x plus y down here, and there's nothing that can reduce with that 2 right there. So that's the answer. Now I've got a little bit of an uglier problem. For example, number 9, it's the same concept. We've got fractions within fractions. We've got the main fraction bar right here. We've got the main fraction bar right there. And if you look at all the different denominators, the denominators are 10x and 2 and 15 and x. So what would be the least common multiple or the lowest common denominator of all these denominators? Well, with 10 and 2 and 15, the first common multiple is the number 30. And with this x and that x, their common denominator would be x. So the key to this problem is multiply all the terms in this problem by 30x. So again, it just becomes a really big distribution problem. So it's going to be this 3 times 30x over 10x plus this 1 times 30x over 2 all over, there's your main fraction bar right there, this 7 multiplied by 30x over 15 plus this 4 multiplied by 30x over x. Okay, now we're going to start cleaning up. On this one, the 10 and the 30, can reduce. That 10 would become a 1, that 30 would become a 3, and those x's can both reduce each other away. So, this first fraction is simply 3 times 3, which is 9. Now on this one, the 2 and the 15 can reduce to become, the 2 and the 30 can reduce to become a 1 and a 15. So 1 times 15x is 15x. Down here, the 15 and the 30 can reduce to become 1 and 2. So 7 times 2 times x is 14x. And on this one, the only thing that can reduce is that x and that x. So this becomes 4 times 30, which is 120. Now let's try to clean up some things. 9 plus 15x. I can factor out a GCF of 3, and I'd be left with 3 plus 5x. Down here, I know they both have a 2 in common, so I'm going to factor out a 2, and you're going to be left with 7x plus 60. Now, I don't see any reducing that can happen, so there's our answer. And everything in this problem started with the idea of multiplying all the terms by 30x, because that was the lowest common denominator of all the denominators. For the last example, which is example number 10, what we're doing is we're simplifying actually 3 fractions this time. We're adding 3 fractions together, and if you look at their denominators, they appear to be all 3 different. So we would need the lowest common denominator or the least common multiple in order to simplify this. Well, we've been doing this all along, but there are a couple of problems on the worksheet that specifically ask you to fill out this format. First of all, if we take a look at the denominators, one of the denominators is the binomial x minus 5, one of them is x, and one of them is x squared. So the lowest common multiple would be the x squared that you're going to get from these two. You don't have to go to x cubed. You can go with x squared and the x minus 5. So what those two problems do toward the end of the worksheet is they just give you this option box. And these are your choices. Put any combination of these in where they belong. So let's work on the common denominator first. The common denominator of these 3 denominators would be x squared and the binomial x minus 5. That would be the lowest common denominator. Now, what they're asking you to do to fill in these top boxes is simply, what would 8 be multiplied by? So if you look at the denominator of the 8, it's the x minus 5. So the 8 would have to be multiplied by the x squared. The denominator of the 11 is an x. Well, if this is the common denominator, the 11 would have to be multiplied by an x minus 5, because the denominator does not have the x minus 5 in it. But it would also have to be multiplied by another x to bring this x up to the level of x squared. Now the 3, the denominator for the 3 is the x squared. So the only thing the 3 needs to get multiplied to make it complete is the x minus 5. Now, the problem doesn't want you to do anything more than that. So that's the answer.